by binomial theorem, we can express the two-term expansion. That means we know a plus b to the power 0. That means the power of a plus b is 0. So that will be 1. We know that very well. Okay. Now, if there is a plus b to the power 1, that means the power of a plus b equal to 1, then that will be a plus b. Okay. Now, a plus b to the power 2. That means this is the formula of a plus b. Hi, welcome back to our channel AnganaStudyCenter. Today we will discuss about the binomial theorem, chapter number 7, class 11. Okay. So first, we learn about binomial. Till now, in class 10, we have learned about the polynomial, but here binomial. Here binomial mean bio mean 2, okay, and nominal mean term, okay. So here this theorem represent two-term expansion, okay. A theorem by which we can expand two-term expression, okay. Let's see, A is a term and B is also a term, okay. Then this is two distinct terms, okay. If we write A plus B, this is a binomial term, okay. This is a binomial. That means here this is one term and this is the two term. So this consists two term, okay. By binomial theorem, we can express the two-term expansion. That means we know a plus b to the power 0. That means the power of a plus b is 0. So that will be 1. We know that very well. Okay. Now, if there is a plus b to the power 1, that means the power of a plus b equal to 1, then that will be a plus b. Okay. Now, a plus b to the power 2. That means this is the formula of a plus b whole square. So we know that a square plus 2ab plus b square. Okay. Now, if we write a plus b to cube, so the power of a plus b equal to 3. So this is the formula of a plus b whole cube. So we know a cube plus 3 a square b plus 3 ab square plus b cube. Okay. Till now, all are good. Okay. If there is a plus b to the power 4, what will be the value? So some we have know that, but maximum percentage don't know how to find that. Okay. From this, just imagine, from this theorem will help us. Okay. Just see. A plus b to the power 0 equal to 1. A plus b to the power 1 equal to a plus b. Okay. A plus b square equal to a square plus 2ab plus b square. Okay. A plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b. Okay. And there are so much. Okay. Till now we have known up to this. Okay. So by this, some observation has been come out. Okay. Then look here, when the index, that means power, is 0, this is the term. Okay. Terms. These are the terms. Okay. When index is 0, term is 1. Okay. So for 0, 1. When the index is 1, term is 2. A plus b, that means 2. So index is 1, term is 2. When index is 2, term is 1, 2, 3. Okay. So index is 2, term is 3. Okay. Here index, here term. Okay. And here index is 3, term is 4. 1, 2, 3, 4. Okay. So similarly, if there is a plus b to the power 4, that means there are 5 terms. 1, second, third, fourth and fifth term. Okay. So when 4 index, term will be 5. in this way we can find if there is n index, that means a plus b to the power n. So we will get here, we see the term will be 1 more than the index. Okay, so term will be n plus 1. So what observation we have found? We have found in the expansion of an expression, the number of terms will be 1 more than the index, that means power of the expression. Okay. Okay. So one observation we have found. Next, here just look the power of the first quantity. Here in this term, first quantity is A and second quantity is B. So just look here, the power of first quantity, that means A is 2. Okay, and here this power of the A is 1 and here 0. So by this, firstly the power is 2, then from there 1 and after 0. Okay, so we can express this as the power or index of the quantity of the first quantity go on decreasing 1. Okay, and similarly just look, we go from here to here, and if we go from here to here, then look here the power of B is 2 and here power of B is 1 and here 0. So and also if we found this, here the power of B is 0, here power of B is 1 and power of B is 2, that means increasing. Okay, similarly the second quantity's power or index will increasing by 1. Okay, in the successive term. Okay, that means here the power of A will decrease by 1 in successive term, and similarly the power of B will increase in successive term. If we go from this side, if we go from this side, the power of B will decrease and the power of A will increase. Okay, so we have found the second observation also. Just look, in each of the term, the sum of the power of the quantity is equal to the index of the expression. Okay, then look here A square. So here the power of B is 0. So 2 plus 0 equal to 2. So 2 is equal to the index of A plus B. Okay, so the observation, the sum of the power of each term of the first and second quantity of an expansion of expression is equal to the power of the expression. Okay, here they look B square, that means B square into A to the power 0, that means 2 plus 0 equal to 2, that means equal to 2. Here also the power of A equal to 1 and B equal to 1, so 1 plus 2, that means 2. Okay, similarly in this case we also found that. So we have found 3 observations. Okay, clear? Now we will know about the coefficient of term. That means if we express this type of expression, Now here a plus b whole square equal to a square plus 2ab plus b square. So the coefficient of a square equal to 1, coefficient of ab equal to 2, b square equal to 1. So if we don't know this square formula or cube formula or this to the power 4 formula, so how we can find that? A simple, very simple method. Here just look, a plus b to the power 0 equal to 1. So the coefficient is 1. Okay, just write here 1. Here a plus b to the power 1 equal to a plus b. So the coefficient of a is equal to 1 and b equal to 1. So just write here 1 and 1. Okay. Now a plus b whole square, the coefficient of this 1, 2 and 1. Just write here 1, 2 and 1. Okay. Just here the coefficient of a cube 1, a square plus b equal to 1, 3, ab square 3 and b cube 1. Okay. And similarly a to the power 4 1, a cube b 4, a square b square 6, ab cube 4 and b to the power 1. So in mathematics there is a particular pattern, okay, or logic. Here just look at this pattern. Here if you look that just 1 from 1 and 1 from 1, okay, and here 1 from 1 and here these 2 1, if we sum these two 1 we get 2 and for this one we get 1. Okay. Now if we sum 1 and 2 we get 3 and 2 and 1 we get 3 and for this one we get 1 and for this one we get 1. Okay. Similarly 3 1 4, 3 3 will be 6, 3 1 will be 4 and for this one 1 and for this one 1. Okay. So obviously all these expansion follow a pattern. Okay. A French mathematician Pascal observe this pattern, and here just look, there is a triangle. If we join this, okay, here also triangle, here also a triangle, here also a triangle. Okay, this triangle is known as Pascal triangle. Okay, this triangle are known as Pascal triangle. By this pattern or this expression we can find the higher coefficient expression. That means a plus b to the power 5, a plus b to the power 6, etc. If we 4 plus 1 equal to 5, 4 plus 6 equal to 10, 4 plus 6 equal to 10, 4 plus 1 equal to 5, and for this one we get 1 and for this one we get 1. Okay, this is the coefficient of the term of a plus b to the power 5. And similarly we can get 5 plus 1 6, 5 plus 10 15, 10 plus 10 20, 10 plus 5 15, 5 plus 1 6 and this one 1 and for this one 1. Okay, this is the coefficient of the expression a plus b to the power 6. Okay, but if there is a question, find the coefficient of the term a plus b to the power 17. Can we find by this triangle theorem, Pascal triangle theorem? Yes, obviously we can find that, but this is laborious. This expression will be very big. Okay, so to reduce this labor, there is another theorem. Okay, another formula. In previous chapter we have learned about combination. Here we will apply the combination formula. Okay, to find out the expansion and the coefficient of the expression. Okay, just look here, a plus b to the power 0. The index is 0 and coefficient is 1. We have previously learned that. Here a plus b to the power 1, index 1, coefficient 1 and 1. A plus b whole square, index 2, the coefficient 1 to 1. And a plus b whole cube, index 3, and we found 1 3 3 1 as coefficient. Okay, so in the combination chapter we have found that NCR equal to n factorial divided by r factorial into n minus r factorial. Okay, where 0 lesser equal to r lesser equal to n. Okay, Here, then look, this formula, how this formula will work here? Then look, just we take this expression. Okay, here we know NC0 equal to 1 and NCN equal to also 1. Okay, so for this one, first one, we write NC0. Okay, and this, for this last term, we write NCN. Okay, now there, this is the, after 0, this is the first term, so we write here NC1. Okay, and we write here NC2. Okay, here what is the value of n? What is the value of n? N equal to the index. N equal to the index. Okay, so if we put n equal to, for this expression, n equal to 3, so we get NC0 equal to 3C0, that means 1. Here NC1 means 3C1. Okay, that means 3 factorial divided by 1 factorial into 3 minus 1, that means 2 factorial, so that means 3. So we get this 3. Okay, now NC2 equal to 3C2. Okay, that means 3 factorial divided by 2 factorial into 1 factorial, that means we will get 3. So this will be 3. Okay, and for this NCN, that means 3C3, that means 1. Okay, we get this. So by this theorem we get the coefficient also. So in particular, in the binomial theorem, we use this combination theorem, okay, to find out various problems. Okay. Now we will find the expansion of a plus b to the power n. Okay, so just look, a plus b to the power n. Till now we don't know of this expansion. Okay, by the combination theorem we can write this as, we first write NC0. Here in every expression we have seen that the first term will be the first term power will be the same as this term, and after that there will be NC1. Here the power of the first term will be decreasing by 1. Okay, that means n minus 1, and when decreasing by 1, then the second term will arise. Okay, similarly then this NC1 will be NC2. Okay, then the power of the first term will be decreased by 1, that means n minus 1 minus 1, and the power of the b will be increased by 1, that means b1 plus 1. Okay, in this way up to NCN term. Okay, there will be the power of a equal to 0 and the power of b equal to n. Okay, where n is a positive integer. Okay, in this chapter we will find this expression when n is a positive integer. Okay, for all positive integer value of n. Okay, now so in general we can write this as summation r equal to 0 to n NCR a to the power n minus r dot b to the power r, where 0 lesser equal to r lesser equal to n. Okay, this formula will be help us to solve various problems in this chapter. Okay, if there is a minus b to the power n, what will be the expression? This is also simple. Just here we can write this as a plus minus b to the power n. Okay, in this place, all this place, just put the value of b as minus b. So we get NC0 a to the power n plus NC1 a to the power n minus 1 into minus b plus NC2 a to the power n minus 2 minus b square plus dot 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 NCN a to the power 0 minus b to the power n. Okay, so in particular we write this as a to the power n minus nc1 a to the power n minus 1 into b plus nc2 a to the power n minus 2 b square minus nc3 a to the power n minus 3 b cube plus dot 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 plus minus 1 to the power n into b to the power n. Okay. So in general, for the positive, we get the coefficient sign will be plus 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 dot dot dot, all are plus. But in minus, the coefficient sign will be plus minus plus minus dot dot dot. Okay, this should be remembered. Now we will do some example for better understand this matter. Okay, look at this example. Here x square plus 3 by x to the power 4 while x not equal to 0. Just apply the binomial theorem. We get here n equal to 4, so 4c 0 x square to the power 4. Okay, 4c 1 x square to the power cube dot 3 by x, 4c 2 x square whole square dot 3 by x whole square. Okay, plus 4c 3 x square dot 3 by x whole cube plus 4c 4 3 by x to the power 4. Okay, so we get x to the power 8. Here 4c1 is equal to 4 factorial divided by 3 factorial into 1 factorial, and here this will be x to the power 6 dot 3 by x plus 4c2 equal to 4 factorial divided by 2 factorial into 2 factorial x to the power 4 dot 9 x square plus 4c3 equal to 4 factorial divided by 3 factorial into 1 factorial into 9 into 3 equal to 27 by x cube plus 4c4 equal to 81 by x to the power 4. Okay, just simplify. Here 3 factors will be cancelled out, so there will be 4 x to the power 6 into 3 by x. So here 4 into 3 into 2 factorial will be cancelled out, divided by 2 x to the power 4 dot 9 by x square plus here 4 into 27 by x cube plus 81 by x to the power 4. Okay. Sorry, here x square will be here, so here x square will be here, so just here x to the power 5. Okay, here x square, here 2, and here x. Okay, so x to the power 8 plus 12 x to the power 5 plus 54 x square. Okay, plus 108 by x plus 81 by x to the power 4. This will be your answer. Now just look at this question. Compute 98 to the power 5. If there is a this type of question, so just divide this number by that term which we can express smoothly. Okay, so just here 98 equal to, we can write 100 minus 2. Okay, so just apply the binomial theorem. Here 100 to the power 5 plus 5c1 100 to the power 4 dot minus 2 plus 5c2 100 cube dot minus 2 square 5c3 100 square minus 2 cube 5c4 100 dot minus 2 to the power 4 5c5 minus 2 to the power 5. Okay, so here 5c1 equal to 5 factorial divided by 4 factorial. So 4 factorial and 5 factorial equal to 5 into 4 factorial. 4 factorial will be cancelled out. Therefore, there will be 5. Okay, into 100 into minus 2. Okay, plus for this term 5 factorial 5c2 equal to 5 factorial divided by 2 factorial into 3 factorial. So 5 into 4 into 3 factorial, 3 factorial, 3 factorial will be cancelled out. 5 to 10. Okay, 10 into 100 cube equal to this minus 2 square equal to 4 plus 4. Okay, and 5c3 equal to 5 factorial divided by 3 factorial into 2 factorial. So there will be 10 into 100 square, and here will be minus 8. Okay, and 5c4 equal to 5 into 100 into 16 plus 16 minus 2 to the power 4 equal to, and here will be minus 32. Okay, if we compute this minus 10. Okay, and for this 40 minus just look at this question. Which is larger? 1.01 to the power 10 lakh or 10,000. Okay. Just use here the binomial theorem. 1.01 equal to, we can write this 1 plus 0.01 to the power 10 lakh. Okay. So just apply that formula. We get here first term will be 1 and then 10 lakh C1. Okay. Into 1 to the to the power that minus 1, that means to the power minus 1 dot 0.01. Okay, plus dot dot dot. Okay, so just here 1 plus here this will be 10 lakh factorial divided by 1 factorial by into 10 lakh minus 1 factorial. Okay, into 0.01 plus dot dot dot. Okay, just here this will be the 10 lakh. Okay, here 0.01 equal to 1 divided by 100 dot dot. So this will be cancelled out. So here 10,001. Okay, so plus dot 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 dot. So this is obviously greater than 10,000. Okay, clear? This type of example problems solved in this way. Okay, let's look at this example. Using binomial theorem, prove that 6 to the power n minus 5n is always leaves one divided by 25. Okay, so then look here, 6 to the power n minus 5n equal to, we can write this 6 should be written by this 1 plus 5 to the power n minus 5n. Okay, just apply the binomial theorem. So here 1, here nc1 5 plus nc2 5 square plus nc3 5 cube plus nc4 5 to the 4 plus dot 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 ncn 5 to the power n minus 5n. Okay, so we can write this here 1 plus here ncn equal to n dot 5 plus nc2 5 square equal to 25, here nc3 5 cube equal to 25 into 5, here nc4 5 to the 4 equal to 25 into 25 plus dot 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 5 to the power n. Okay, minus 5n. So then look, 5n plus 5n minus 5n will be cancelled out. So we have plus here nc2 25 plus 25 nc3 5 plus 25 nc4 5 square plus dot 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 25 dot 5 to the power n minus 2. Okay, so 1 plus, if we common 25 from this, we have nc2 plus NC35 plus NC4 5 square plus dot 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 5 to the power n minus 2. Just imagine this is a number. Okay, so 1 plus 25k, where k equal to NC2 NC35 plus dot dot up to 5 to the power n minus 2. So we get 6 to the power n is equal to 1 plus 25k. So if we divide this by 25, there should be 1 as remainder. So 6 to the power n minus 5n is leaves a remainder 1 divided by 25. Okay, proved. Clear? So that's all for today's class. If you like this video, please subscribe our channel and press the like button. Please share with your friend. Thanks for watching our video.